for moments about origin, moments about mean. After the brief introduction of moments about mean, moments about origin, we discussed about the definition of moment generating function. Now it's time to apply all those, and we solve the first example related to the moment generating function. So find the moment generating function for the random variable x having density function. Having density function means what kind of random variable it is? Can anybody tell me just by reading the question? When you say it is a probability function, it is discrete. When you say density function, it is continuous random variable. So question में कैसा function दिया है वो न देखते हुए भी whatever language is used in the question or the example, we can easily decide. So in this case, we have the density function which is given by f of x, and how it is defined as e to the power minus x for x greater than equal to 0 and 0 for x less than 0. Whenever there is a negative index and limits are up to infinity, we don't have to worry because we always have the answer for e to the power minus infinity as 0. Yeah, limit extending to infinity, e to the power minus x will give you the answer as 0. Determine first four moments about origin and also find the first four moments about mean. First four moments about mean and origin. सबसे पहले जो अपन ने moments about पढ़े थे, those were moments about mean, which is mu r, which is given by expectation of x minus mu whole square, right? And mu r dash is nothing but moments about origin, which is given by expectation of x to the power r. Find the moment generating function. Now we know that it is very simple from moment generating function to calculate the moments about origin. This is the formula. If you differentiate the moment generating function that many times, you get the first four moments. अच्छा, हमेशा कैसे कितने moments पूछे जाएंगे आपको? First four moments पूछे जाएंगे. First four moments means 1, 2, 3, 4. Mu1 dash, mu2 dash, mu3 dash, mu4 dash. So first I calculate the moment generating function and then I go with the calculation of the moments about origin, and वो relationship वाले statements use करके we can easily calculate the answer or value for the moments about mean. So accordingly, since x is a continuous random variable, mx of t is expectation of e to the power tx. And what is expectation of e to the power tx? Given by e to the power tx into f of x dx, where it should be integrated between 0 to infinity. But our function is e to the power minus x, which is only defined for x greater than equal to 0. So for x greater than equal to 0, limits of integral are 0 to infinity e to the power tx into e to the power minus x dx. E to the power tx is in the definition. Density function is f of x, which I have taken into account, and I multiplied it. So bases are same, powers get added, so I can have it as minus e to the power t minus 1. अभी कोई बोलेगा कि सर tx minus x को आप ऐसे करो ना कि x कॉमन ले लो, it will be t minus 1 into x. बट इंटेंशनली मैं यहाँ पर नेगेटिव क्यों चाहूंगा? क्योंकि इफ यू पुट अपर लिमिट एज इंफिनिटी, x की जगह इंफिनिटी आने के बाद t minus 1 into infinity will be infinity, and e to the power infinity will give you the answer as infinity. एंड अपने को इंटीग्रल का आंसर इनफाइनाइट नहीं चाहिए, सम वैलिड आंसर चाहिए, बिकॉज इन केस ऑफ डेफिनाइट इंटीग्रेशन, ये कैसा केस कहा जाता है? व्हेन इट इज बाउंडेड बिटवीन द लिमिट, it is considered as the case of definite integration, and always in case of definite integration you have the finite value as the answer. So intentionally, by knowing that one of the upper limit is going to be infinity, I will purposely make it as negative. And how it is converted to negative? By taking minus common. Now when you integrate this, e to the power minus 1 minus e of multiplied by x का integration क्या होगा? E to the power minus of 1 minus tx upon minus of 1 minus t. Put the upper limit as infinity. E to the power minus infinity is 0. E to the power 0 is 1. After simplification, you get the answer as 1 upon 1 minus t. So what is the moment generating function obtained as? Moment generating function is obtained as 1 upon 1 minus t. I hope all of you have understood that why I am not taken it as t minus 1 into s. Purposely, intentionally converted to minus of 1 minus t, because looking at one of the limit of integration, whenever the limit of integration is infinity and if it is a negative power, you get the answer as 0. And so that we are able to find out the answer for the moment generating function, which will be always a finite quantity. So आपको क्या मिला है? Moment generating function 1 upon 1 minus t. Now, as per the Taylor's series expansion, what we have learnt over here, in the Taylor's series expansion, coefficient of t will be mu1 dash, coefficient of t square upon 2 factorial will be mu2 dash, coefficient of t3 upon 3 factorial will be mu3 dash. So similarly, if I have to calculate the first 4 moments about origin, I should find out the expansion in ascending powers of t, and then their corresponding coefficients will be moments about origin, right? So what is the expansion for 1 upon 1 minus t here? 1 upon 1 minus t can be written as 1 minus t to the power minus 1. And what is expansion for this binomial term? The expansion for this binomial term is 1 plus t square plus t cube plus t to the power 4 and so on. बट मुझे पता है कि मोमेंट जनरेटिंग फंक्शन अगर इस तरीके से लिखा गया, so I can have the coefficient of t as mu1 dash, t square by 2 factorial as mu2 dash, t cube by 3 factorial as mu3 dash, t to the power 4 factorial as mu4 dash. यहाँ पर किसकी कमी है? 2 factorial. किसकी कमी है? 3 factorial. अरे multiply and divide by those terms. So if you compare them, if you compare this, mu1 dash क्या होगा? Coefficient of t, which is simply 1. Coefficient of t square means 2 factorial. 2 factorial is 2. तो आपका आंसर mu2 dash कितना आएगा? 2. Coefficient of t cube by 3 factorial. 3 factorial नहीं है, तो मैंने multiply and divide by 3 factorial कर दिया. तो 3 factorial is nothing but your 6. And mu4 dash के लिए मैंने क्या कर दिया? Multiply by 4 factorial and divide by 4 factorial. So what is the coefficient of t to the power 4 by 4 factorial? 4 factorial. What is the value for 4 factorial? 4 into 3 into 2. 12 2s are 24. So after expanding the moment generating function by using the binomial expansion, I have got the answer for moments about origin. ये हो गया one of the method to calculate when the expansion is very simple. If the term is not that very simple, आपको क्या करना है? डेरिवेटिव लेना है that many times to calculate dt. You have to calculate the derivative as per this formula. क्या है? dr by dtr of the moment generating function. r का वैल्यू 1 चाहिए, वन टाइम इंटीग्रेट करो एट t, डिफरेंशिएट करो एट t इक्वल टू 0. r का वैल्यू 2, सेकंड मोमेंट अबाउट ओरिजिन, 2 टाइम्स डिफरेंशिएट एट t इक्वल टू 0. थर्ड वैल्यू 3 टाइम्स डिफरेंशिएशन एट t इक्वल टू 0. दिस इज आल्सो वन ऑफ द वे to calculate the moments about origin. But here, looking at the given term, binomial expansion was very simple, and therefore I use the Taylor's series expansion or the binomial expansion to get the values of mu r dash, which is moment about origin, from the coefficient of t square, from the coefficient of t cube, and from the coefficient of t to the power 4. Clear? So I have got the answer for mu1 dash, mu2 dash, mu3 dash, and mu4 dash. Now you know the relationship. What are the relationship between moments about mean and moment about origin? The first 4 moments about mean will be mu1, mu2, mu3, and mu4. mu1 is always 0. ठीक है? Calculation कैसे होता है mu1 का? mu1 is nothing but expectation of x minus mu, which is expectation of x which is mu. Mu minus mu is 0. Expect mu2 is variance of x. अपन ने ये निकाला था mu2 dash minus mu square. So accordingly you will be calculating the answer which is giving you 2 minus 1. Mu square यानी क्या होता है? Mu. Mu is nothing but mu1 dash, right? So accordingly you have to find out what is mu1 dash. Mu1 dash is 1. So we get the answer which is 2 minus 1 is 1. This relation I have told you, mu3 dash decreasing order में mu2 dash, mu cube increasing order में. According to that particular result we get the answer for mu3 as 2. For mu4 using this particular result, mu4 dash, mu3 dash, mu2 dash, फिर mu square mu to the power 4 इंक्रीजिंग ऑर्डर में. अकॉर्डिंगली यू नीड टू कीप इन माइंड ऑल्टरनेट प्लस माइनस है, यहाँ प्लस है माइनस है प्लस है माइनस है. कोएफिशिएंट इज 4 6 3. अकॉर्डिंगली यू नीड टू कीप दिस स्टेटमेंट इन माइंड और रिजल्ट इन माइंड एंड दैट आंसर कम्स आउट टू बी 9. सो कहने का मतलब है I first calculated moment generating function. From moment generating function whatever is the result expand it if possible, otherwise use the derivative formula. You get moments about origin. Moments about origin हमेशा पूछे जाएंगे first 4 moment, यानी mu1 dash, mu2 dash, mu3 dash, mu4 dash. 4 values are nothing but first 4 moments about origin, right? So therefore we got mu1 dash, mu2, mu3 and mu4. Now mu1 is first 4 the one of the first moment about mean. mu1 dash is always 0 क्योंकि इसका फॉर्मूला होता है ये. mu2 dash, mu3 dash, अभी expectation of x is mu minus mu is 0. mu is nothing but mu1 dash. mu1 dash आप निकाल चुके होते हो, तो अकॉर्डिंगली यहाँ अलग से एक्सपेक्टेशन नहीं भी निकाला तो भी आपका आंसर आपको मिल जाएगा. So that will be giving you the first value. Use the second relation, third relation. आपके चारों moments about mean can be easily calculated. So this is the way to calculate the moment generating function, moments about mean, moment about origin. This particular example was the example related to the continuous random variable wherein you integrated. Now आपको ये एग्जाम्पल जो दिख रहा है वो किसके लिए दिख रहा है? शायद डिस्क्रीट के लिए है. फाइंड मोमेंट जनरेटिंग फंक्शन एंड फर्स्ट 4 मोमेंट्स अबाउट ओरिजिन फॉर रैंडम वेरिएबल x. व्हाट इज गिवन? x is 1 whose probability is 1 by 2. It is minus 1. Still its probability is 1 by 2. डिस्टिंक्टली नंबर दिख रहे हैं, तो ये रैंडम वेरिएबल विल बी आइडेंटिफाइड एज केस ऑफ विच रैंडम वेरिएबल? discrete random variable. Discrete random variable में it is summation. So moment generating function will be expectation of e to the power tx. Expectation of e to the power tx will be multiplied by probability function and over summation. x का वैल्यू क्या क्या है? x का वैल्यू 1 है और x का वैल्यू is -1. So एक जगह x का वैल्यू 1 लेते हैं तो e to the power t into 1 by 2 which is the probability plus x का वैल्यू -1 लेने से it becomes e to the power -t and corresponding probability is again 1 by 2. So दो ही random variable है तो 2 terms will be there in the summation. Now this converts to the formula of hyperbolic cos and hence we got to the simplification or the derivative or deduction of this moment generating function as cos ht. I hope it is clear. In random variable only 2 values are obtained, 1 as well as -1, and both the corresponding probabilities are 1 by 2. So x का वैल्यू 1 पुट करो, उसका corresponding probability 1 by 2 लीजिए. x का वैल्यू -1 पुट करो, उसका corresponding probability 1 by 2 लीजिए. So I am getting moment generating function as cos ht. Now first 4 moments about origin. Origin बोले तो mu1 dash whose answer is expectation of or whose formula is expectation of x to the power r. Mu r dash का formula क्या है? I will be using it. mu1 dash means expectation of x. Expectation of x square means summation x into f of x. 1 into 1 by 2 plus -1 into 1 by 2. Its answer is 0. Secondly, mu2 dash is expectation of x square into f of x. 1 square into 1 by 2 minus 1 square into 1 by 2. 1 by 2 plus 1 by 2, answer is coming out as 1. Mu3 dash means expectation of x cube into f of x. 1 into 1 by 2 minus 1 cube into 1 by 2. Again, answer comes out to be 0. Expectation of x to the power 4 is mu4 dash. Origin है तो 1 to the power 4 into 1 by 2 minus 1 to the power 4 into 1 by 2. Again, answer is 1. So what are the first four moments about origin? Mu1 dash is 0, mu2 dash is 1, mu3 dash is 0, mu4 dash is 1. So this was the example of or case of discrete random variable where we had the moment generating function and moment about origin. मोमेंट अबाउट ओरिजिन का डेफिनेशन होता है mu1 डैश, mu r डैश इज इक्वल टू एक्सपेक्टेशन ऑफ x टू द पावर r, या फिर टेलर सीरीज एक्सपांशन से निकालो या फिर डेरिवेटिव निकालो मोमेंट जनरेटिंग फंक्शन, यू गेट द मोमेंट अबाउट origin. This is the way of calculating the moment about origin. Now, one of the example again which is very peculiar, that is moment generating function of a random variable which is given by the density function. So this is x by 2 for 0 less than x less than 2 and 0 otherwise. क्या निकालने के लिए बोला है? मोमेंट जनरेटिंग फंक्शन एंड फर्स्ट फोर मोमेंट अबाउट ओरिजिन. मोमेंट अबाउट ओरिजिन मींस अगेन मोमेंट जनरेटिंग फंक्शन का टेलर सीरीज एक्सपांशन निकालो या you differentiate the moment generating function, you get the corresponding moment about origin. Moment about origin पर से दो तीन relationships जो दिए हैं, you get the moment about mean. So usually in many of the examples you will find that moment generating function is directly connected with the moments about origin. So for a continuous random variable, again integration will be taken. Here the range of integration will be 0 to 2. So moment generating function is expectation of e to the power tx, integration from minus infinity to infinity, e to the power tx into f of x, e to the power tx into x by 2, because range of integration is 0 to 2. Now 1 by 2 को बाहर, apply Lie rule, algebraic function and then exponential function. Applying integration by parts and putting the limits, you get the answer as e to the power 2t. ये first into integration of second, x into integration of e to the power tx is e to the power tx upon t, minus derivative of t is 1, t square in the denominator, integration of e to the power tx is e to the power tx. Common LCM लीजिएगा, put the lower limit, upper limit, you get the answer, and simplification for moment generating function is this. Now how to calculate moment about origin? Moment about origin to be calculated by the definition. Mu1 dash is expectation of x. Expectation of x is x into f of x. This is very simple. Normal function का algebraic term का integration है. So your answer comes out to be 4 by 3. X into x by 2 is x square by 2. Integration of x square is x cube by 3. Put the limit 0 to 2. Expectation of x square will be the second moment about origin, that is mu2 dash. X square into x will become x cube. Integration of x cube is x square by 4. And what is the answer after putting the limit? You are getting it as 2. What is mu3 dash? Mu3 dash is expectation of x cube. How to calculate the expectation of x cube? X cube into f of x. F of x is x by 2. X cube into x is x to the power 4. Integration of x to the power 4 is x to the power 5 by 5. And accordingly, my answer comes out to be 16 by 5. How to calculate the fourth moment about origin? It is mu4 dash is expectation of x to the power 4. Means x to the power 4 multiplied by f of x. X to the power 4 into x is x to the power 5. And what is integration for x to the power 5? Integration for x to the power 5 is x cubed by 6. Put the limit 0 to 2, you get the fourth value, that is 16 by 3. So from the moment generating function, this is your moment generating function. Moments about origin are used by the formula mu r dash is equal to expectation of x to the power r, and this is how we calculate the first four moments about origin: mu1 dash, mu2 dash, mu3 dash, mu4 dash. So that many times the expectation will be calculated, and expectation is nothing but multiplying by that term to the probability function or the density function. Expectation of x means x into f of x. Mu2 dash will be expectation of x square, means x square into f of x. Mu3 dash will be expectation of x cube, means x cube into f of x. Mu4 dash means expectation of x to the power 4, means x to the power 4 into the function. And that is how we try to calculate the first four moments about origin. So in this case, we get the answer as first four moments about origin: mu1 dash, mu2 dash, mu3 dash and mu4 dash. इसके आगे अगर बोलते हैं कि मोमेंट अबाउट मीन निकालो, सो वी विल बी यूजिंग द रिलेशन mu1 will be expectation of x minus mu. What is mu1? Mu1 is expectation of x minus mu. Mu2 will be expectation of x minus mu whole square, that is variance of x जिसको बोला जाता है. mu3 के लिए क्या है? रिलेशन है आपके पास. mu4 के लिए आपके पास रिलेशन है. So accordingly you can calculate from moment about origin the values for moments about mean. So this was all regarding